Today we're going to talk about linear functions. As we're going through these few examples on our linear functions over the next couple of pages, we're going to be using all of these different equations that are up at the top. So kind of going through each of these different things one by one. Our standard form of our equation, ax plus by equals c. A and b are both not zero at the same time, so that way we have two variables. And the thing to think about when we're looking at our standard form is that our equation looks nice. X and y are on the same side, they're in order. Generally speaking, if we have fractions, we get rid of fractions. So standard form is just kind of a nice way to present our equation. Right, our slope-intercept form, y equals mx plus b. Right, that's a very useful type of our equation. It's useful for graphing. It tells us a lot about the direction of our line, how steep it is it going up, is it going down. Our m, the coefficient of x, is always our slope, and b is always the y coordinate of our y-intercept. Our point slope form, y minus y1 equals m times x minus x1. Again, m is always our slope. x1, y1 is a point on the line, and this gives us a way of an easy way of generating the equation of a line if we are given different information rather than a slope and an intercept. Right. Our other equations and definitions, our slope, right, is our vertical change over our horizontal change, our rise over run. It's given by the formula y2 minus y1 over x2 minus x1. And then our intercepts are the points of our graph where our function lies on an axis. We talked a little bit about these the other day, and we said as we're thinking about our intercepts, if we have an x-intercept, it's going to be on our x-axis, so we're going to have a value for x and then a 0 for y. A y-intercept is on our y-axis. We're going to have a 0 for x and a value for y. Underneath here on this first page for the section, we also see some other useful tips. We're going to talk a little bit about solving an equation for y, which we'll use as we go through one of our examples in the next few pages. And then we're going to talk a little bit about graphing. So all of these different things on this first page are tools that we're going to refer back to as we go through the next group of homework problems. Right, so down at the bottom of the page, the first thing that we're going to do is we're going to talk about slope. When we are talking about slope, we're always going to use this equation that's listed up top here. So we're going to start all of these examples by writing out our equation. The goal is, if you keep writing it out and working through it, by the time we're done with this section, that you should have all of these memorized. So our slope, our m, is y2 minus y1 over x2 minus x1. Right? And we're going to use this equation for both example A and B. Right. As we're going through and labeling these, our subscripts, the 1 and the 2, refer to what point these values are coming from. And it's up to you. I usually label my first point with my 1s and my second point with my 2s, and then put them into my formulas that way. You can reverse it the other way. The key thing is here, just watch your signs. Make sure that your 1s and 2s are matched up. Make sure you're not getting them confused as you're plugging into your equation, and make sure you're paying attention to your signs as you're plugging these in. So using this first ordered pair, this 1, 2 is our x1, y1, and this 3, 5 is our x2, y2. Right? X is always our first part of our ordered pair, y is always the second part of our ordered pair. If we go through and fill these numbers in then, right, our y2 is 5, minus y1 is 2, over x2 is 3, minus x1 is 1. Right, we go ahead and subtract. 5 minus 2 gives us 3. 3 minus 1 gives us 2. So our slope in this example is 3 over 2. For B, right, here's x1, y1, and x2, y2. Right, so y2 is negative 3. Negative 3 minus 1, because 1 is our y1. Then in our denominator, we have 5 minus 3. Negative 3 minus 1 gives us negative 4. 5 minus 3 gives us 2. We're going to go ahead and reduce this fraction into lowest terms to give us negative 2 over 1, but we are going to leave it represented as an improper fraction. Same thing with example A. Right? We almost always think about slope as a fraction, So whether it's proper or improper, it doesn't really matter. We don't necessarily want to change it into a mixed number. Because if we look at A, what this means is between every 2 points on our graph, we are going up 3 and then to the right 2. Because our slope is our vertical change over our horizontal change. Everything's positive, so we're going up and to the right. In B, we have a negative slope. That means that we are going down and to the right. So in this case, our second line here has a negative slope, so instead of going up, we would be moving down as we're moving between points. In these next few examples that we're going to go through, we're going to focus on and think a lot about our slope-intercept form of our graph. Our slope-intercept form of our graph of a line, again from the previous page, is y equals mx plus b. M is our slope, and b is the y-coordinate of our y-intercept. So using this information, in example A, we are given y equals 1/2 x minus 1. So our coefficient of x, our number connected to x, is always our slope. So in this case, our slope, our m, equals 1/2. Our y-intercept is always 0, comma, and then whatever number we have over here, -1. Because if we plug 0 into this equation, half times 0 is still 0. 0 minus 1 is still -1. So by plugging in 0 for x, it wipes out this middle term, and all we're left with is this number that's over there. So when we're given an equation that's in slope-intercept form, we can easily pick out our slope, and we can easily pick out our y-intercept. Our x-intercept is going to take a little bit more work. When we're dealing with an x-intercept, we're going to plug a 0 in for y, and we're looking for an x value. So what this means is I'm going to take my original equation here, and I'm going to plug 0 in for y. So 0 equals 1/2 x minus 1. Right, we need to get x all by itself, so I'm going to add 1 to both sides. 1 equals 1/2 x. And then to get rid of my fraction, I'm going to multiply both sides by 2. Right, so x turns out to be 2. You can multiply to get rid of the fraction first and then add if you want. Either way, we should end up with x equals 2 for our answer. So our x-intercept, we take that value, we put it in next to our y-coordinate of 0, so we get an x-intercept for this first one of 2, 0. All right, next couple are going to look very similar. So we're going to start with our slope. So in example B, y equals -x plus 3. Our slope, in front of our x is an invisible 1. We think about slope as a fraction, so I'm going to write it as -1/1. Our y-intercept always starts with a 0 for x and then includes this other number for y. So we have 0, 3. Our x-intercept, we're going to plug 0 in for y and find our corresponding x. So 0 equals -x plus 3. I'm going to subtract 3 from each side. -3 equals -x. Divide by -1. X equals 3. So our x-intercept is 3, 0. We do have options as we're solving these. If you would have rather added x to both sides, either way we still get the same value for x. So we have a slope of -1/1, an x-intercept of 3, 0, and a y-intercept of 0, 3. Right, for example C, right, our slope, again, is our number connected to our x. So our slope is 3. As a fraction, we're going to write that as 3/1. Our y-intercept, right, if we plug 0 in for y, well, 3 times 0 is still 0. So we get, if we plug 0 in for x, we get 0 for y. Right? To find our x-intercept, we're going to plug 0 in for x. Right? Well, if we plug 0 in for x, then 0 equals 3 times x. Either way, we get 0, 0. In this case, our x-intercept and our y-intercept are the same. They are the point that is the origin. And that is because when x equals 0, y equals 0, and the other way around. When y equals 0, x equals 0. Looking at our equation, it looks like our slope is here. It looks like our intercept over here is missing. So that's another way you can sometimes tell that your y-intercept is going to be 0, 0, which then makes your x-intercept for your linear equation also 0, 0. Example D looks slightly different. In example D, notice that we start with x and the y on the same side. This is an example of our equation being in standard form. So the first thing we want to do is we want to take our equation and we want to take it out of standard form and put it in slope-intercept form. So I'm going to rewrite my equation over here. 4x plus 2y equals 8. Now on the previous page, where it said other useful information, we had two different things that were mentioned. One of them is solving an equation for y, which is changing our standard form to our slope-intercept form. That's what we're going to use here. Right, so the first thing we're told to do is to either add or subtract the x term. So looking at this, we have a positive x term, so we're going to subtract 4x from both sides to cancel that out. So now we have 2y equals negative 4x plus 8. I wrote the x term in front of our constant term because when we're thinking about our equation of line in slope-intercept form, we usually have the x term before our constant term. Right? Now when we're dealing with our slope-intercept form, we need to have y all by itself. So the next thing we're going to do is we're going to divide by 2 to get rid of that coefficient. Well, whatever we do to that y, we're going to do to every piece of our equation. Okay. So we have y equals negative 2x plus 4. Right, these all divide nicely and evenly, giving us a nice equation, no fractions or anything. If they don't divide evenly, then just make sure you reduce our fractions. All right, so based on this new equation that we have, now our equation is in slope-intercept form. Again, our slope is our number next to our x, so our m is negative 2 over 1. Our y-intercept is 0, 4, because that's the other number in our equation. To find our x-intercept, we're going to plug 0 in for y to find our x. We could use this one. We could go back up to our original equation. It doesn't really matter. I'm going to plug 0 into my original problem. So 4x plus 2, we're going to replace y with 0, right, equals 8. Right. Well, 2 times 0 is just 0. Right, so basically that whole second part of our equation on the left side disappears. Right, we get 4x equals 8. And if we divide both sides by 4, we get x equals 2. So our x-intercept is the point 2, 0. So as you're going through the homework, you're going to see some that start in slope-intercept form, some that start in standard form that you're going to have to then switch over. Again, our slope is always our coefficient of x. Our y-intercept is always the constant term that's by itself. And then to find our x-intercept, we make sure that we let y be equal to 0. All right, the next few problems that we're going to work on this next page, we are going to go through and we are going to be working on finding equations of lines. Then just to do some practice, talk a little bit about graphing. We're going to graph these as well. In the homework, you're not necessarily going to be asked to graph a ton of these, but it is just kind of a nice review as we're going through and thinking about our linear functions. All right, so we are asked to write the equation of line in function form and standard form, and then we're asked to sketch a graph. So the first thing that we're going to do is we're going to label the pieces of our problem. In this first example, right, we have a line with a slope of 2/3 and a y-intercept of 0, negative 1. Right, our slope is always represented by the letter m. The y-coordinate of our y-intercept is always represented by the letter b. So what we're going to use is we're going to use our slope-intercept form of our equation. Y equals mx plus b. And we're going to plug the information in that we have. Right? So we're going to keep our y as a y. M we're going to replace with 2/3. Right? X stays an x. And b is a negative 1, so we're going to write minus 1. So what we have here is our equation in slope-intercept form. Notice that our answer asked for our equation of our line in function form. Function form means we're just going to replace this y with our function notation f of x. So in function form, our answer is going to be f of x equals 2/3 x minus 1. So function form is our slope-intercept form, and we're just replacing our y with our f of x. We are also asked to find this in standard form. So as we are looking at this in standard form, we want to get x and y all by itself, and then we generally like to get rid of fractions if we have fractions. So I'm going to take my slope-intercept form that I have here and recopy it next to my problem, because we're going to use that to generate our standard form. Right. When we're going from slope-intercept form to standard form, well, we're going to do the reverse of what we did in the previous problem, where we changed from standard form to slope-intercept form. So I want my x and my y on the same side. So first thing I'm going to do is subtract 2/3 x from each side. Right? So either way we're going, we're moving our x to the other side. Right? Slope-intercept form, we want y all by itself. Standard form, we want x and y on the same side. So now we have negative 2/3 x plus y equals negative 1. Technically, this is standard form. However, if we can, we want to avoid fractions. So looking at this, we have a fraction with a denominator of 3. So just like we did back in chapter 2 when we were solving rational equations, we're going to multiply everything by our LCD. Right, so we're going to multiply all of our terms by this 3. Right, so those are going to cancel. We're going to be left with negative 2x plus 3y equals negative 3. So our two pieces to our answer, right, our function form is this f of x equals 2/3 x minus 1, and our standard form is negative 2x plus 3y equals negative 3. Right. Now when it comes time to plot this, right, when we're sketching our graph, we're going to use and go back to our function form, which is our slope-intercept form. So the first thing we're going to do is we are going to plot the point 0, negative 1. Right, we're going to start with our y-intercept. So 0, negative 1 is this point right here. Y-intercept should always be on our y-axis. Then we're going to use our slope. Our slope in this particular equation is 2/3. That means as we're going from point to point, we're going to be moving up 2 and over 3. So starting at my y-intercept, we don't want to start at the origin. When we're doing our second point, we want to start at the y-intercept. From this point, we're going to go up 2, 1, 2, and then to the right 3, 1, 2, 3. Now, if you want to, you can move up 2 and over 3 again to get another point up here. Or we could go down here and we could reverse the process to get another point over here. Once we're done with this, we have a minimum of 2 points to create a straight line. So we are going to connect our dots that we have here. And there is a sketch of our linear function. So we started with our slope and our y-intercept. We took those to come up with our slope-intercept form, which gave us our function form. We then switched that slope-intercept form to standard form, which gave us the equation in green. And then we plotted 2 points to get a line that we could then sketch in. Right. B is going to be set up very similarly to example A. Right. We're told that we have a line with a slope of 2 and a y-intercept of 0, 0. So our M is 2 and our B is 0. Right. Again, we're going to start with our slope-intercept form, y equals mx plus b, and we're going to plug the appropriate numbers into our equation. So we keep the y. We're going to have negative 2 for our slope, so we have negative 2x plus 0, which we can just rewrite as y equals negative 2x. This is going to give us our function form, f of x equals negative 2x. Right, to get our standard form, we're going to go back to our slope-intercept form, and we're going to get x and y on the same side. So again, I'm going to start by recopying this. Y equals negative 2x. We want x and y on the same side, so I'm going to add 2x to both sides. Right. On the right, they cancel. On the left, we have 2x plus y, and on the right, since they cancel, we have a 0 left over. Right. As far as plotting our points, the first thing we do is we plot our y-intercept. Our y-intercept, right, it looks like it's missing. We plug in 0 for x, we get 0 for y. Right, our y-intercept is also given to us up here. We plot our 0, 0, and then we're going to use our slope of negative 2. So we're going to start at our origin and put a point there. And a slope of negative 2 means we're going to move down 2 and to the right 1. So we move down 2 and to the right 1. Again, if you want to add another point in here, we could. Right. At least 2 or more if you would like to connect our dots. Right, we have a nice straight line. So here is our sketch of our linear function. Right, so in both example A and B, we were given a slope and we were given a y-intercept. So we could jump right in and start with our slope-intercept form. Right, now if we look at the information that's presented to us in example C, notice that we are given different information. Right? We are still given our slope, so we are still given our m, but instead of being given a y-intercept, we are giving a random point on our line. So this random point I'm going to label x1, y1. So thinking about our equations of lines, we can't jump right in with our slope-intercept form of our equation. This is where that other form that was listed at the beginning of the section comes into use. We're going to use our point slope form. Y minus y1 equals m times x minus x1. Right? The way these equations are named are based on the information that we're given. Right? In A and B, we were given our slope and our intercept. That's what we had in our equation of our line. In this case, we're given a slope and we're given a point. So we're going to use our point slope form of our line. Right? So we're going to start plugging everything in. The plane x and the plane y we're going to keep just like we did up here. We kept the plane x and plane y, so we're going to do the same thing here. So we're going to have y minus y1 we're going to replace with 3. Our m is 4. We keep our parentheses, keep that first x, and we're going to replace that x1 with a 1. So we're replacing our slope, and we're replacing our x and our y with our subscripts. Right, we're replacing our x and our y with the subscript of 1 based on that point that they're coming from. Right, now we're going to clean this up because in order to get it in function form, we want it in slope-intercept form, which means we want y all by itself. So y minus 3 equals 4x minus 4. Right, we want to take this and we want to distribute it to both parts of our equation that are in parentheses. And then we want to get y all by itself, so we're going to add 3 to both sides. Y equals 4x minus 1. Right, we lined the 3 up under our other constant terms since they are just numbers. Then to write this in function form, f of x equals 4x minus 1. Right, now the other thing we want to do, we want to write this in standard form. So f of x equals 4x minus 1. We're going to use our y equals 4x minus 1. So we're using our slope-intercept form. We want x and y on the same side, so we want to move this 4x to the other side. Negative 4x plus y equals negative 1. So function form, we take our slope-intercept form and replace it with f of x. Standard form, we take our slope-intercept form and then we rearrange it to get x and y on the same side. Right. So to graph this, we're going to start by plotting our y-intercept. Our y-intercept, we're going to go to this equation down here. Our y-intercept is 0 and then the number that's by itself, our constant term. So we're going to have 0, negative 1. And then our slope is 4. Right. So we're going to write it as 4 over 1, which means we're going up 4 and to the right. So 0, negative 1 is our y-intercept, and then to get our next point, we're going to go up 1, 2, 3, 4, and then to the right 1. Again, we can move, estimate, do another point if you would like, but 2 points is enough for us to sketch in our linear function. All right, so a few more examples on the next page. We're going to start example D. Looks very, very similar to example C. We're given a slope of negative 3 over 2, and we're giving a point on the line x1, y1. So just as we did in the previous example, we are going to start with y minus y1 equals m times x minus x1. We're going to plug in the information that we have. Y minus 2, so our y1 is 2, equals m negative 3 over 2 times x minus negative 4. When we are calculating slope, when we are plugging things into our equation, we do want to pay careful attention to our signs. So the left side is easy. We have y minus 2. On the right side, we're going to distribute this negative 3 over 2. Negative 3 over 2 times x is just negative 3 over 2x. Now we need to multiply this negative 3 over 2. These two negatives are going to turn positive. And so we're going to take this negative 3 over 2 and multiply it by positive 4. A couple of different ways we can work through doing this. If we take negative 3 over 2 times 4 over 1, we can either multiply and then cancel, or cancel and then multiply. I'm just going to multiply straight across. We get negative 12 over 2, which is negative 6. So make sure as we're distributing, if you do need to multiply fractions, you can multiply straight across and then cancel. But we do need to multiply both our x and that now positive 4 by negative 6. All right, to finish this off, we're going to add 2 to both sides. Y equals negative 3 over 2x minus 4. That's going to give us our function notation. F of x equals negative 3 over 2x minus 4. Right, to get our standard form equation, we're going to start with this slope-intercept form. So we're going to start with y equals negative 3 over 2x minus 4. Right, we're going to move our x term to the other side. So we're going to add 3 over 2x to both sides. So we have 3 over 2x plus y equals negative 4. And then we're going to get rid of our denominator. So we're going to multiply everything by 2. 2's cancel. We have 3x plus 2y equals negative 8. So there's our equation in standard form. Then to sketch our graph, we're going to start by plotting our y-intercept. Again, our y-intercept from our slope-intercept form or function form is 0, negative 4. And then we're going to use our slope, which is negative 3 over 2, which means we're going down and to the right. Alright, so we start by plotting our y-intercept, which is 0, negative 4. Now normally from here, using our slope, we would go down 3 and to the right 2. So we could draw that in and kind of sketch and say, well, our point's going to be right around there. Our other option would be to reverse it. So instead of going down 3 and to the right 2, we could go up 3 and to the left 2. Right? That would line up with that other point that we would be plotting right there. So you do have options as you're doing your graphs. If you're sketching graphs, just make sure that you have at least 2 points that give you the correct slope, the correct movement. So we're going to sketch in our graph here. And there is our sketch for that linear function. Alright, so A and B were similar. We started off with our slope-intercept form. C and D were similar. We started off with our point-slope form. If we look at E and F, we are given different information. What we are given here in these, we are actually given 2 points. Okay. So what we have here is an x1, y1, and an x2, y2. Before we can do anything, the first thing we need to do is we need to find our slope. So we're going to use our slope equation, y2 minus y1 over x2 minus x1. So then as we plug these in, y2 is 6 minus y1 is 2, x2 is 5 minus x1 is 3. This gives us 4 over 2, which then reduces to 2 over 1. Now that we have our slope, we can use our same point slope formula that we did in example D. So y minus y1 equals m times x minus x1. So y minus, and you can use either point that you want to. I'm going to use the one that's labeled x1 and y1 just to make sure I don't mix anything up. So y1 is 2, so y minus 2 equals m is 2 over 1. We can write it as a whole number just to make our calculations a little easier. So our slope is 2. X minus x1, we go back up here, is 3. So we have 2 times x minus 3. As we did in the previous 2 examples, we're going to start by distributing. 2 times x is 2x, 2 times negative 3 is negative 6. We're going to add 2 to both sides. Y equals 2x minus 4. In function form, f of x equals 2x minus 4. In standard form, we're going to start with this y equals 2x minus 4. Subtract 2x from both sides. So negative 2x plus y equals negative 4. Then to sketch our graph, we start by plotting our y-intercept, which here we're going back to our slope-intercept, our function form, which is 0, negative 4. And then we're going to use our slope of 2 and move up 2 and over 1 to get our next point. So 0, negative 4 on our y-axis is here, and we're going to move up 2 and over 1. Again, if you would like to add in additional points, you can, but that gives us enough to draw a nice sketch of our graph. So if we are given 2 points, we do have a little bit more work to do. Before we can find our equation of our line, we do have to do the calculations to find our slope. Again, as we're working through every step of these, we want to pay careful attention to the signs of all of our different numbers. Make sure we're watching our positives and negatives. All right, so one last example to finish off this section. So we are given 2 points again, so I'm going to label these x1, y1, x2, y2. So we're going to go through our same process in example E that we did, in example, it should be F, as we did in example E. So we're going to start m equals y2 minus y1 over x2 minus x1. So we're going to plug in our values. y2 is 5. Minus y1 is negative 6. So we have 5 minus negative 6. X2 is negative 6 minus x1 is negative 5. These guys turn positive up here. So our m is positive 11 over negative 11, which we can reduce to negative 1 over 1. Right. Now that we have our slope, we can use our point slope form. So y minus y1 is equal to m times x minus x1. Y minus negative 6 is negative 1 times x minus 5. This gives us y plus 6 is negative 1x plus 5. We're going to subtract 6 from both sides. Y equals negative 1x minus 1. In function form, we can write f of x equals negative x minus 1. To get our standard form, we're going to come back to our slope-intercept form. Y equals negative 1, x minus 1. We're going to add x to both sides. X plus y equals negative 1. Then finally, to sketch our graph, we start with our y-intercept. Our y-intercept, again going back to this equation, is our negative 1. Our slope is also negative 1. So on our graph, we start with our y-intercept of 0, negative 1, and then we move down 1 and to the right 1. Again, add as many points as you feel necessary, and then we can connect our dots to get a nice straight line. Okay. So in these last two examples, again, we've had multiple steps to work through. Right. First, we find our slope. Once we have our slope, then we can use our point slope form to find our slope-intercept form. Our slope-intercept form gives us our function form. We can then use our slope-intercept form to give us our standard form, and then we can use that to sketch a plot of our graph.